So today we're looking at question 104, maximum depth of a binary tree. Given a binary tree, we need to get the maximum depth of a tree. So if you see example 1 right here, we have, this is the first layer 1, second layer 2, this is 3. And if you see a few more examples and try to visualize this. So this is a visualization of this particular tree. Here we see that it's 2 because it's a root and then one of the children, and then here it's empty, so the height would be 0, and here the root has a particular value, so it would be 1. So it's a pretty simple problem to understand, and let's look at the solution now. The way we'll be approaching the solution is by keeping a global variable that keeps a track of the maximum height that we've seen so far, and we keep calling the method to calculate the height recursively on a particular node as long as it's not null. The space complexity would be O of n. Just in case if the tree is unbalanced, you'd keep calling it recursively on one particular branch, and then all of the calls would stack up. So that would be the worst case scenario, so that would be O of n, and then space time complexity would be O of n as well, where n are the number of nodes, so since you'd have to call them n times. So I hope that's simple enough to understand. Let's get started with the solution. So let's start with the global variable maximum height. So let's just initialize this to integer dot min value. Okay, cool. So first let's check the base case. So if root is equal to null, you would just return 0, else you would call a helper method that would take the root and that would keep a track of the current height that you've seen so far. Then you would just return in the end the maximum height. Cool. Okay, so in the helper method itself, you're not really returning anything, so you would just have void helper tree node, and you would see the current height. Let's just initialize that to h. So we would check if if it is not equal to null, then you do the computation. If it is null, you don't do anything with it. So we just implement h, and then you would call this recursively on the left child, and then on the right child. Yeah. And in the end, you just want to calculate the maximum height to be what we've seen so far, or the present maximum height that we have. Okay, so let's just quickly run this, see if it compiles, if everything is okay. Alright, it passes the base case. Let's submit it. Okay, cool. Yeah, so that is how you solve this problem. It's a pretty simple problem. If you have any questions, let me know in the comments below. Don't forget to subscribe.